So we will start with organic chemistry in this semester. We have only one course, that is organic chemistry. And organic chemistry, you know, it is chemistry of carbon and its compounds with nitrogen, hydrogen, oxygen, etc., and a few elements, including a few metals. So, but mainly hydrogen, nitrogen, and oxygen are the elements. And many of the organic compounds are natural compounds, like consisting of life involved compounds like carbohydrates, proteins, amino acids, and all these things you know. So let us look at basic structure and formula and the different aspects, properties in physical and chemical properties of these compounds. The basic, the first organic molecule, you can say it is CH4, that is methane. If you draw the structure of methane, there are four hydrogens on it. You know they are all sigma bonds. They are all sigma bonds. And this is how you draw this molecule on a single plane. But if you look at the three-dimensional structure, how will this molecule look like? Three-dimensionally, if you view this, how will it look like? Can you draw it? Take your time and draw this. I'll give you, say, 1 minute to draw it. Okay. By the time I'll take my model. And once you draw your figure, I will show you the model, and then you have to draw what you are seeing using the model. Don't hesitate. Whatever you feel, you have to draw, you draw it. Then this is the only way of learning organic chemistry, which you have to practice by yourself. You should have a three-dimensional view of the molecule. Okay. So you must be having your own figure in your mind. Now let me show you the model. You can see this model. These white half spheres, you can say they are hydrogen atoms. This is a carbon atom. The black one is a carbon atom. Now see, this is a three-dimensional figure, and you know what is a bond angle. The real bond angle is 120 degree. Real bond angle is 109 degrees, you know that. But remember, when you draw it in the plane, it is 90 degree. So this is actually wrong. Because this is 90, and if you consider this H bond, you take it take the angle from the front, you'll have 180 degree. If you take this angle from the front, it will be 180 degree. So this is it's not a planar molecule. You know that it is a tetrahedral molecule like this. Now look from the front. Now draw it. Now draw it from the front. Okay. How many hydrogens you see? If you exactly look like this from the front, how many hydrogens do you see? How many of them? See that. In fact, you see only 3 hydrogen atoms. You see only 3 hydrogen atoms. This is the one which you are seeing, which I kept my finger. And this also you can see. And this also you are able to see. Right? So these are the 3 hydrogens which you see. And if you consider this is the plane of the board, if you consider this as the plane of the board, then let me draw this, what I am seeing. You have to draw by yourself. You also draw before I draw it. Okay. Now, there are 3 ways you can put a bond. One, a single line. which represents a bond in the plane. The second, a structure like this, bond projecting towards the observer, and then you have dashed line, dotted line structure, which is bond projecting away from the observer, So these are the ways you represent the bonds. Now, in that case, now look carefully. This and this are in the plane of the board. So let me draw that first. So when and remember, you are seeing only three bonds. This and this and this one. And all these three you are going to draw in a single plane, quite naturally. So I'm drawing. I'm sorry. I'm not getting the control of sometimes if I draw it. Where is my, yeah, okay. Let me draw it. Yeah. I draw a straight line down, then one bond here, and this is the third one. Okay. Now see, I will make this as wedge, assuming that this, I don't know whether how you people, when you look from there, how it looks like. I'm doing from my side. If I do it, it should be on the right hand side. Okay, I think I have to change this and make the other one. Yeah, this is all right. I think this I have to make in the, yeah. I think this is how you people will look, or you people will see. So I have made this a dark one. Okay, see, it is this one. This is projecting towards you. This one is projecting towards you. And now you can see, you have the fourth bond. So let me put out the hydrogens here. You have the fourth bond, which I can draw either on this side or on this side. It makes no difference. But the thing is, they should be as close to this bond. Why? Because you are not able to see it. You are not able to see this fourth hydrogen. But still, you have to show there is a fourth hydrogen. So it is actually being eclipsed behind this. That is how you represent it. Make sure you're drawing like this. So if you draw any structure like this, this is wrong. Or if you draw like this, that is also wrong. So this is the only way. Suppose it's the only way you have to represent that. That is, the wedge bond and dotted line should be one behind the other. Okay, if you can draw it on this side or on the top, say for example, why don't you rotate this molecule 90-degree clockwise? Whole molecule you have to hold in your hand and rotate it clockwise 90-degree. 90-degree, 120-degree, sorry, 120-degree. Rotate clockwise 120-degree. How it will look like? See, this bond will come here, and this hydrogen will come here. Okay, but this will not change. H comes here, and see here. H, and H. See that? Rotation, right? You are rotating it 120-degree clockwise. See this. See, this has come here. Same hydrogen, no change in the hydrogen. I can rotate this still further. See this. If I rotate it still further, I'll get this figure. Again, this bond has to be behind this, very close. Actually, this, if you are observing from the front, you can see the angle between these two is 0. And these three are 120 to each other. This is 120. This is 120. And this also is 120. Okay. So this is the three-dimensional structure of methane molecule. So this is how you manipulate the structure. You should have a three-dimensional view in your mind about whichever is the molecule you are drawing. Okay, so that is methane. Can we convert this? Can we convert this into ethane? What's the difference in structure? Methane is CH4. Now what I do is I add a CH2 to this. Okay, that gives me C2H6. Or what I'm doing is, let me put it CH3H. And then I remove this hydrogen and put a CH3 over there. Substitute it. Put it here and take it out. What do you get? CH3, single bond, CH3. This is ethane molecule. Replacing the hydrogen with the CH3. Now let me do the same thing here. I have all these 3 hydrogen atoms. I'm not doing anything with them. I'm putting the hydrogen here. Now here, I'm putting a CH3. Okay, so this is, remember, I'm not talking any chemical reaction here. I'm just asking you to replace one of these hydrogen with a CH3. Now I want you to draw I would like you people to draw the three-dimensional structure of the CH3 group. I'll give you 1 minute. Please try yourself and see how you will fare. That is, expand this CH3 also. Come on, fast. Do it fast. Yeah, do it fast so that you can save time. Okay, you have finished drawing? Please, if you don't do it, even if you are watching this video through the YouTube, as and when I tell you in the this year, anyway, I'm going to draw it here, but as and when I give you the chance, please do it by yourself so that you get convinced of your own answer. Okay. Now let us see how we can fare in drawing the structure. Now see here. See here, you can see we have used 2 bonds in the plane for 1 carbon. So for this carbon also, we can use 2 bonds in this plane. And whenever you draw, do one thing. Already 1 bond is drawn for this carbon. Now we have to draw 2 more bonds, 120 to each other. See here. I know you must have, many of you must have drawn this like this. Many figures will be there. I don't want to analyze that. Only thing is you have to keep this in your mind. If you draw like this, it's going to be 90 here, it's going to be 180 here. What is important is whenever you draw a carbon, whenever you draw on a single plane, make sure they are at 120 to each other. That is all. Here is 120, here is 120, here is 120. That is all what you have to make sure. Now, see here, I will put the hydrogen here and hydrogen here. But remember, one of these has to come to the front side. So I can put either this one or this one, a wedge structure. Let me put this as a wedge structure. Okay. Now you have to put the next one more hydrogen is there. As we have already mentioned, make sure that you are putting the hydrogen always behind the wedge. So dotted line structure should be behind. So this is one form of it. And this one, I'm keeping this intact, the same. And then drawing this. This also I can make wedge, no problem. Okay. Now see. Both are easy. Both are correct. Okay. Both are correct. But there is some difference in the structure, in the form. Let us do one thing. So this is now what you have to do is, can you observe from here? Observe it from here, along this line, along this axis. Along this axis you observe. And this molecule also you observe from this axis. So what you're doing is you're keeping your eye here. Or rather, you're taking a torch and then light it. Okay. Same way here also. You have a torch. You have the hydrogen, hydrogen, hydrogen. And you're applying a torch here, and you have a big screen here. You are going to get a shade here. If you apply the torch from here, you'll get a shade. Right? That shade is what you have to draw. In both the cases, you have to draw that shade. Right? Why didn't you try it? Just try to draw the shade. Yeah. Draw it by yourself and see. You have drawn them? Okay, you can do this by the time we start our next class. Along with that, what you can do is draw the structure of propane and butane and hexane. Just the way you have done with this molecule, this ethane. This is methane, this is ethane, right? So draw the structures of propane and hexane in the same fashion, the three-dimensional structure. And before we start our next class, okay? So that is the basic introduction. We'll take up in the next class how this figure will look like, and what is being represented in this, and what is the difference between these two structures. Okay, thank you.